You know, when we look at a massive mountain, it's so easy to just see it as this permanent, unchanging monument of rock. But the truth? The truth is actually far more violent and incredibly dynamic. So today in this explainer, we're going to literally read the biography of the Earth's crust. And we're focusing on what has to be one of the most awe-inspiring geological structures on our entire planet, the Himalayas.
To really wrap our heads around the sheer scale of the Himalayas, we have to start with a specific number: 8,848 meters. That is the breathtaking height of Mount Everest, literally known as the roof of the world. Sitting right there on the border of China and Nepal, this one peak represents the absolute extreme of what geological forces can achieve. But here's the thing: Everest is just one small part of a much larger story. Section 1. The roof of the world. Let's look at what makes up this colossal natural wonder. We're talking about a massive geological structure that spans 5 entire countries: China, India, Pakistan, Bhutan, and Nepal, absolutely dominating the Asian landscape. Now, geologists actually classify the Himalayas as modern folds. That basically means they're giant wrinkles in the Earth's crust, and relatively speaking, they're pretty young in geological history. Yet, despite being young, they feature 15 of the highest mountains on the entire planet and boast well over 100 peaks that pierce the sky at altitudes above 7,000 meters. It's just wild.
But to trace the true biography of these mountains, we have to travel deep into geological time. You see, the story doesn't actually begin 55 million years ago with the famous collision we usually hear about. No, to really understand the immense forces at play here, we need to rewind the clock way back, over 600 million years ago. We're talking long before dinosaurs, long before complex life even existed, just to witness this epic, recurring pattern of continental destruction and rebirth.
Section 2. The Afro-Brazilian Himalayas. Yes, you heard that right. The Afro-Brazilian Himalayas.
So how do we even prove this deep history? Well, geologists actually look at these incredible microscopic time machines. They're called zircon crystals. Basically, scientists use the uranium decay inside these super resilient ancient crystals to date continental collisions from billions of years ago. Here's how it works. When magma cools down into solid rock, these tiny crystals form, and they lock in a very specific amount of uranium. And from that exact moment, they act as a totally closed system. The uranium inside slowly decays into lighter elements, like lead, at a constant known rate. So by measuring those elements, geologists essentially have a highly accurate, microscopic clock. It's literally a radioactive time capsule.
And when researchers use this method to test matching high-pressure rocks, which are known as eclogites, found in Sierra, Brazil, and way across the ocean in Togo and Mali, West Africa, they found something absolutely astounding. The results proved that a massive 2,500-kilometer mountain range stood right across the ancient supercontinent Gondwana 610 million years ago. Imagine that, a primitive Himalayan-scale mountain range, standing tall right exactly where Brazil and Africa used to be stitched together.
Now, this ancient collision involved a process called subduction, and it happened at mind-boggling depths of over 90 kilometers. Basically, to create those dense eclogite rocks we just talked about, one massive tectonic plate was violently forced deep beneath another. The pressure down there was so incredibly intense that it literally forged massive mountains straight out of the crust. Eventually, those deeply buried, highly pressurized rocks were exhumed. They were literally spit all the way back up to the surface. And get this, it was the very first time in Earth's history that a mountain chain of this staggering magnitude was ever formed.
So you might be asking, why does this matter to us today? Well, because the immense erosion of these ancient Afro-Brazilian mountains literally sparked early complex life. Seriously, picture these towering peaks slowly, relentlessly wearing away over millions of years, eventually flooding the oceans with massive amounts of life-giving nutrients. This ancient geological event essentially triggered a massive biological boom. It led to the multiplication of photosynthesizing microorganisms, an absolutely massive surge in ocean oxygen, and ultimately the very first multicellular creatures during the Eocene period. Talk about a true game changer.
Moving on to Section 3, the end of the Tethys Sea. Let's see how a vast ocean just vanished.
Okay, let's fast forward a few 100 million years. The map of the Earth is dramatically shifting once again. As the great supercontinent Pangaea split apart roughly 230 million years ago, the massive Tethys Sea formed right in the middle of the rift. It basically acted as this vast oceanic divider between the northern landmass of Laurasia, so it's North America, Europe, and Asia, and the southern landmass of Gondwana,
which held Antarctica, Africa, South America, India, and Australia. And for millions of years, this enormous sea was a thriving, bustling home to some truly unique ancient marine life. And we know this because of fossils. By tracking specific fossilized marine life, like the entodontoided fish from the Cenomanian period, that's roughly 93 to 99 million years ago, paleontologists can literally watch how this ocean slowly vanished. Because as the tectonic plates continued their restless march toward one another, the sea shrank. Researchers mapping these exact fossils discovered highly specific, isolated populations. One group was near modern-day Morocco and Italy, and another near Lebanon and Israel. These little pockets of endemic life perfectly highlight how the massive Tethys Sea was literally just squeezed out of existence by shifting continents. Today, it leaves behind only tiny remnants, like the Mediterranean, Caspian, and Black Seas. Which brings us to Section 4, the Great Collision, the birth of the modern Himalayas. Now, this is where things get really crazy. Look at where the Indian Plate actually started its journey. It was way down near the coast of Africa, practically next to present-day Madagascar. Propelled by the intense, churning forces of the Earth's lithosphere beneath it, the Indian Plate completely broke off and just rocketed northeast. It traveled straight across the closing Tethys Sea at what is honestly an incredibly rapid pace in geological terms.
Then, around 50 to 55 million years ago, boom, the Indo-Australian plate violently crashed right into the Eurasian plate. And because of the sheer unimaginable density and momentum of these two titanic landmasses colliding, the Indian plate was thrust downward. It subducted right beneath the Eurasian plate, specifically under what is now Tibet. With nowhere else to go, the massive volume of crust was violently crushed skyward, physically forging a 2,200-kilometer wall of jagged mountains.
The pressure from this impact was just mind-boggling. It triggered a phenomenon geologists call anatexis, which is literally the melting of solid rock deep underground just from the extreme friction of the plates scraping together. It also caused something incredibly rare, inverted metamorphism. See, usually the deeper you dig into the earth, the hotter the rocks become, right? But here, the tectonic chaos was so incredibly violent that older, burning hot rocks from deep below were physically shoved right over the top of younger, cooler rocks along a massive fault line known as the main central thrust. It's this extreme, chaotic structural upheaval that ultimately forged the absolute highest peaks on planet Earth. And that takes us to Section 5, a living mountain range. Because this story is far from over. You see, this explainer isn't just about ancient history. The tectonic collision never actually stopped. It is happening right now, right this very second, deep beneath all that snow and rock. The Indian plate is still relentlessly sliding about 2 to 2.5 centimeters under Eurasia every single year. And because of that continuous push, the Himalayan mountain range is physically growing. It's pushing upward by about 4 millimeters annually. Now, obviously, that escapes the human eye. But don't let the slow pace fool you. That immense, continuous pressure is building terrifying, relentless seismic tension deep underground.
And that hidden pressure, it creates a very real, terrifying danger for the people living there today. Just to put it into perspective, experts have identified 95 active fault lines in Nepal alone. The math is incredibly stark. If the tectonic plate moves 2.5 centimeters a year in 100 years, that's 2.5 meters of pure geological tension just waiting to snap. A sudden release of that energy could easily trigger an 8.0 magnitude earthquake on the Richter scale. That kind of rupture could potentially destroy 60% of Kathmandu's infrastructure. And tragically, when it comes to disaster preparedness, things are severely lagging. The country struggles with poverty, and any mitigation efforts are really hampered by the poor coordination of 28 different government agencies.
Yet, despite those truly terrifying earthquake risks constantly hanging over the region, one local geologist pointed out a really striking paradox. He observed, and I quote, "Nepal wouldn't exist without this movement. We would probably be part of India or China." Think about that. This relentless tectonic violence, the exact same force that threatens their daily lives, is the very thing that gave Nepal its distinct geographical existence. It forged its breathtaking topography, and it created the booming tourism industry that sustains them in the first place.
The Himalayas are this incredible, towering reminder that we live on a restless, shifting planet. From those ancient Afro-Brazilian peaks that literally seeded our oceans with early life, to the slow vanishing of the vast Tethys Sea, right up to the monumental peaks that scrape the sky today, our world is in constant, spectacular motion. So as this unstoppable geological engine keeps running, and as the immense pressure continues to quietly mount beneath the roof of the world, it leaves us with one crucial question. When the crust finally slips again, and it will,
Will modern populations be prepared?